Set 4. A water reservoir with unlimited water content is connected to 5 water tanks A, B, C, D, and E, directly or indirectly as shown in the figure below using pumps P1 to P8. Each pump can be calibrated to allow the flow of water such that the water flows only in one direction. The arrows indicate the direction of the flow of the water. The capacity of the water tanks A, B, C, D, and E is 200, 250, 100, 150, and 200 in million liters respectively. The connecting pipes between any two water tanks can allow the flow of any volume of water through them. The reservoir releases only the exact amount of water such that each of the water tanks just fill up. If a pump gets shut down, then no water flows through the said pump. So these are the arrow signs that tells us the direction of the movement of the water. And these P1, P2, P3, P4 up to P8, these are nothing but the pumps. So from here we can see that the water tank A is connected by only one pump. Same is true for B and D. C is connected by one pump, while D is connected by 3 pumps and E is connected by 2 pumps. Okay. Let's look at the questions and try to understand what we have to do. So the questions are, the first one is theta, next one is a definite, next theta, next one has one option as cannot be determined, again a theta. So most likely most of the questions are going to give us the accurate answer. Let's go ahead and solve this. So the best way to solve this is, let's draw a table wherein we'll be talking about each of these 5 pumps, their capacity, and the 5 water tanks, their capacity, which all are the inlet pumps, or what are the pumps that are attached to that particular tank, what is the amount of water getting in and what is the amount of water getting out. Okay, so we will need a table for that. So we will have the tank and the volume. We will write it in bracket itself, and then we'll be using the pump, then the volume getting in, and then the volume getting out. So for each of these cases, so we will draw these 4 columns and let's fill up that table. So this is what we have. The water tank, they are A, B, C, D, E. Their capacity are from the main stem of the set. Now, if you look at tank A, the pump is P1. If you look at B, the pump is P2. If you look at C, the pump is P3. If you look at D, there are 3 pumps associated, which are P4, P5, and P6. If you look at E, there are 2 pumps, P7 and P8. Now, if we assume that there is X liters of volume that is getting in A, and if there is, let's say, Y liters of volume that are getting in B, and if the total volume is 200 plus 250, 450, 550, 6, 7, 8, 900. So total volume is 900 liters. So if all the tanks are supposed to be filled, so we can say that from pump 4, 900 minus X plus Y volume is being pushed through from P4, right? So let's put in these values. At A, let's put X liters. In P2, let's put Y liters. For P4, it's going to be 900 minus X plus Y. Okay, let's talk about P3 now. In P3, if you're going to have Z liters that is getting in C, that means the volume that will come out towards P5 is going to be X minus Z. So X is the inlet part. Whatever is left, that goes there. So this is going to be X minus Z. Not exactly X minus Z. So let's understand this. From X total volume, A is going to be filled, which is going to be 200 liters. Z is going to be filled. And then this is the remaining that will go in P5. So from here, can we say P5 is actually going to be x minus 200 plus z, right? Okay. And from P6, if y is the overall inlet and B has a volume of 250, so from that, whatever is the leftover, the remaining part will go in P6. So this is going to be y minus 250. Now, if you look at C outlet, the total volume that was getting in was Z. C has a volume of 100. So the volume that will pass through P7 is going to be Z minus 100. And if you look at D, the total volume that it is passing through, it is going through is x minus 200 plus z, 900 minus x plus y, and y minus 250. If we add all of this and the capacity of D is 150, if we subtract that, that is the volume that will get in through P8, the 8th pump. So let's put in these values. At P3, if we take this as Z, then P5 we will have x minus 200 plus z. At P6 we will be having y minus 250. At P7 we will be having z minus 100. And at P8, so let's add all these values. Plus x and minus x will cancel out. And then plus y and minus y will cancel out. 900 minus 200 minus 250. 900 minus 450 is 450. 450 minus 150 is 300. 300 minus z. So we will have 300 minus z passing through P8. If we add P7 and P8, we will be getting 200. That's exactly what the volume will be. If we add P4, P5 and P6, we will be getting 150 if we will add all of this. Okay. So 150 plus 200. So 350 is what we will be getting. So we will have 900 minus 200 minus 450. So, okay. If we add all of this, we will have 450 minus z. And if we add all of this, this is going to be 200. Okay. Now, the outlet volume, if we talk about it, the outlet volume from A is two component. It is one this Z part, and then this is x minus 200 plus Z part. If we add both of these, we will have x minus 200. Similarly, if you talk about from outlet B, there is only one component that is going out, which is y minus 250. If we look through C, the outlet is merely Z minus 100. If we look at outlet of D, this is going to be what enters from here, which was 300 minus Z was getting in. So this is going to be 300 minus Z. And if we look at outlet of E, nothing is being taken out because E is our last water tank. If we pay attention, since it is given in the main part of the question that each of the water tanks should be filled, the volume of T is 100 and C is going to get the volume or C is going to get water only from A. So the range of X is going to be 200 to fill itself and another 100 to fill C. So X is going to be at least 300. From here, with when it comes to Y or the B water tank, so B outlet enters water tank D. Now D can be filled using pump 5 or pump 6 or pump 4. So that is not an issue. That B is responsible in filling water tank D. So for Y, as in the volume that is getting into water tank B, it should be greater than equal to 250. Now, if we compare the last two as in C and D, because A is the final water tank. So from here we can say that Z is going to be at least 100 and it's going to be at most 300. So this is the range of the values of XYZ that we have to consider and we have to take care of while solving the questions. Question number 17. If the ratio of the volume of water flowing in water tank D, flowing in, which is 450 minus Z, and flowing out of it, which is 300 minus Z, is 4:1, then what is the volume of water flowing through P7? So we need to find out Z minus 100 from here. So as per the question, 450 minus Z is to 300 minus Z. This is 4:1. So if we cross multiply, we will have 450 minus Z is equal to 4 into 3, 1200 minus 4Z. If we rearrange this, we will have 3Z is equal to 1200 minus 450, which is 750. This will result in Z being 250. So if Z is going to be 250, Z minus 100, the one that is asked, is going to be 250 minus 100, which will be 150. Since it's a theta question, we are supposed to type in 150. 150 is going to be the answer. Question number 18. P4 is shut down. So if P4 is shut down, that means 900 minus x plus y is going to be 0. So that will result in x plus y is equal to 900. This is the first part. And the second part is if the ratio of the volume of water in million liters that flows into P3 and P6, they are in the ratio 3:2. So from this, we can say that Z upon Y minus 250 is equal to 3:2. This will give us 2Z is equal to 3Y minus 750. Then what is the minimum volume of water through P1? So we need to minimize X. Now, if you look here carefully, X is going to be minimized when Y gets maximized. And if Y gets maximized, that means Z gets maximized. So this tells us that if I want to minimize X, I should maximize Z. Because if Z increases, Y will increase. And when Y increases, because of the first equation, we will now have the smallest possible value of X. Now, in order to do so, let's use the first equation, and from here let's write y is equal to 900 minus x, and let's put this in the second equation. We will have 2z is equal to 3 times 900 minus x minus 750. So this will result in 2z is equal to 2700 minus 3x minus 750. This is going to result in 2z is equal to 2700 minus 750 is going to be 1950 minus 3x. Now, if we look at the two conditions that we have on x and z, so it is known that x is going to be greater than equal to 200 and z is going to be greater than equal to 100 and it's going to be less than equal to 300. So this is what we know of. So if we subtract, x is greater than equal to 300. If we subtract, we will get x minus z is going to be greater than equal to 200 for sure, right? If x minus z is greater than equal to 200, now what we can do is we can eliminate x from both of these, or what we can do is let's keep the inequality. From here we can write x is equal to 1950 minus 2z whole divided by 3. Let's put this over here. When we put it over here, we will have 200 is less than equal to 1950 minus 2z upon 3 minus z. This is going to give us 600 is less than equal to 1950 minus 5z, or z is going to be less than equal to 1950 minus 600, which is going to give us 1350 upon 5, which is going to give us 270. So z is going to be 270 or less. That means the maximum value that z can take is 270. If the maximum value that z can take is 270, that means if we put this value of z over here, the minimum value that x is going to take is going to be 470. So the answer is going to be option C, 470. Question number 19. If P6 is shut down, so we are talking about y minus 250 is going to be 0, which implies y is going to be 250. Then what maximum volume of water can flow through P4? So let's look at P4. So this is the maximum volume of, this is the volume of water that flows through P4. If we want to maximize this, so x is going to be minimum. So the minimum value of x that we can have is 300. And the value of y has turned out to be exactly 250. So 300 plus 250, when we subtract this from 900, this is going to result in 900 minus 550, which is going to result in 350. So 350 million liters is going to flow through P4. And this is the maximum possible. If we increase the value of x to be more than 300, so we will have a reduction of more than 550 from 900, and the volume of water will decrease. Since we need to maximize it, we'll keep x as minimum. So the answer is going to be 350. Since it was a theta question, we had to type in 350. Question number 20. If P2 allows 300 million liters of water to flow through it, so this is 300, then what is the ratio of the water reaching the water tank D from water tank B? So water tank B to D, so we are talking about P6 over here, because from B y minus 250 is being taken out, the volume, and that volume is fed here through P6, and the rest of the water tanks together. So let's begin. Okay. So if you talk about this, this is going to be y minus 250, which is going to give us y we know is now 300 minus 250, which is going to give us 50. So we know that part. This part we know is 50. And the rest of the water tanks together. So if we talk about the water the water reaching water tank D from the rest of the water tanks together, it will be from the other two, P4 and P5, right? So this, if we add, is going to give us 700 minus y minus z. X will cancel out because x is common. So this is going to result in 700 minus 300 minus z, which is going to give us 400 minus z. Now, since we don't know the value of z, z can be anything from 100 to 300. So the ratio of 50 and 400 minus z can be a lot of different cases. So hence the answer is going to be cannot be determined. Option D. Question number 21. If an equal amount of water enters tank A through P7 and P8, then what is the volume of water entering tank C through P3? So we need to simply find out the value of Z. So as per the question, Z minus 100 is same as 300 minus Z. So this results in 2Z is equal to 400, or Z is going to be 200. So since it's a theta question, so we have to type in 200, which is 200. Question number 22. What is the volume of water in million liters entering through P4, P5, P6 and P7? So we need to find out sum of all this. So which is going to be, let's take care of the numbers first. So we will have 900 minus 200 minus 250 minus 100, which is going to be minus 550. 900 minus 550 is going to be 350. Then let's take care of the variables. Minus x and plus x will cancel out. Minus z and plus z will cancel out. And then we will be left with minus y and plus y. Oh, okay. So this also gets cancelled out. So we're left with only 350 as the answer. So which is going to be option D.